Okay, so this video is a build video on how to build and construct this robot arm lifter. Um, this thing I use to test the strength of motors, how much weight it can lift, and also you can attach it at different aspects to understand the lever principle. Like when you connect it here on the first rung, it really does not lift a lot of weight. It's really interesting. Second, third, fourth, it's really not until the fourth hole that this will really start to lift some pretty heavy bookage. You may want to use books. I use basically a little uh, piece of wood with string on it, which I can show you right here. Yes, this right here, which you can construct this out of MDF or plywood or whatever, and then I have these carabiner or whatever to connect to the another carabiner through a metric 5 screw, machine screw, and then you can just stack books on here, and yeah, like that, and see how many books can you lift and so on. You can have a little postal scale just to say, okay, how much does this book weigh? Many books just weigh 1 pound or 2 pounds, and that gives you a good estimate, a good guide of how much weight this motor and rack and pinion can lift, and you can compare the various leverages. So, in fact, you can also compare the leverages down here by connecting the other part of the rack and pinion, which is helpful. So there's no real one method of constructing these robots. This is a robot building kit. So, in this particular instance, I put an accelerometer on here. This can be used to tell you how fast it's moving. You can record all that information, log it in real time if you have the RT preempt configured, which is the default for the Banana Pro. I'm not sure for the Raspberry Pi, but very well could be, and I'm sure it'd be very easy to just rebuild the kernel with that if you needed to. So this one has just an accelerometer. I just screwed it in there. In this particular orientation, it's important to have the orientation. Currently, 3 are possible with this robot app. One is the flat normal method with Y forward, Y plus forward, X plus to your right. This one happens to be the vertical one with Y minus to the front and X plus to the right, and also handles Y minus to the top, Y minus to the top, and X plus to the left, which would be the other side of this vertically. Those are the 3 possible combinations. So, and that can be set in software. So, okay, what are components? But there's some basic components that you need. Like, you don't really need the accelerometer, a gyroscope, or an ETH Excel to run this mechanical arm. All you really need is an ETH motors, which is here in the middle. And you need also an Ethernet connection to some kind of computer. It could be your personal computer, home computer. It could be a PC. It could be a Mac. It could be something running Ubuntu or some other flavor of Linux, other distribution of Linux. So that's all. Just to connect to that ETH motors with a network cable. So basically how you do it, you construct this arm. It's very simple to construct. You have the 3D printed pieces, and then you just run a metric 5 screw through, and there's an embedded nut in this hinge. You just screw it through. You can even use a drill with a screwdriver attachment. You can see there are embedded nuts in the various holes for the arm. You just want to pick one of those and screw through a metric 5 screw, machine screw. I think this is about a 40 millimeter length, and that will connect to your rack. See the other video about how to make a rack and pinion linear actuator. It's very simple. You just have the 3D printed parts and a clamp and coupling and a few metric 3 screws, and should be no problem at all. Okay, so that's basically the arm, and oh yeah, the other thing, if I get my neurons, the same thing for the rack and pinion connects with a metric 5 screw. Very simple, very easy to connect this arm, and I clamp it to a table. You know, I can include the clamp in the kit or not. I'm sure most people have one or can easily get one. So this one though, if you're going to use more than just an ETH motors, you want to use an accelerometer, you're going to need an ETH accels. And so how that connects is basically an RJ12 cable. Now crimping an RJ12 cable is very simple. You can buy RJ12 cable on eBay or AliExpress very cheaply, and also the little plastic adapter ends, connector ends. I like this better than other terminals because it locks in place. You know, it's just like a phone cable. If I can get it to, here it goes. It locks in place very nicely. It's not going to come out when the robot's moving around and so on. And so it takes up a little more space than maybe a regular wire terminal, but it just holds it, I think, a little bit more firmly. But also you're having six, it would be a 6 terminal. You know, you'd have quite a large terminal there for 6 wires. It's one or the other. You know, I mean, you can easily take those PCB files and make it a 6 terminal if you feel that that's a more compact and better design, and use wire. And the same thing for the ETH accels, just change that terminal connector. But you know, the RJ12 is a cheap and simple solution. You also need the RJ12, RJ45 connector, or crimper, sorry, to do that. First you'll just strip off a little bit of that RJ12 cable, and then put in your plastic piece, put in that cable, insert the cable in the plastic piece, put the plastic piece with the cable connected in there, and crimp it, and then you're done. It's very simple and straightforward. And this cable is much easier than making a network cable. You know, it just, the flat cable, I was looking then for flat Ethernet cable. I got some, but it didn't work the way I expected it to. So, but this one does. This one's a very simple solution. So, okay, if you're going to have more than two PCBs, if I could get my neurons, you're going to need an ETH switch, which is this one. This is a 16. I'm also in the process of getting some 8. It's not fully 8-port ETH switches made. Now, this one is not fully populated. It only has 5 RJ45s. You can do the same thing. You know, if you want to just, you only need 2 or 3, why populate all the rest if you're making the PCB yourself? So, okay, so you have to connect the network connections. Both the ETH motors and the ETH accels are going to connect to your switch. Then also, your host computer, whatever it is going to connect to that switch too. Whether it's your Raspberry Pi or your Banana Pro or whatever it is, that network switch is going to connect in there, and that's the only thing that you need to connect. You don't need to share the powers or anything, just the network. The brain connects with the network cable, that's all, which is really a cool thing with this design. So then for the ETH motors, you're going to connect your motor to your ETH motors. That's these 2 wires here into this header. This is actually motor, see, 0 starts here, 0, 1, 2, 3, motor 4, 5, 6, 7, motor 8, 9, 10, 11. This is motor 11. And so I tend to put in the positive first and then the negative after that. That's my own personal preference. And it's really simple. You can even use your finger just to press down on the pins, you know, to insert the wire. It's a little difficult with both my hands, or one of my hands holding this thing. But you don't need really even a screwdriver to press this down. You can just use your fingernail or even just your finger, and that makes it very easy to connect and disconnect these motor wires. I mean, there's an alternative, like having a connector and connect all your motors together and then click it into the PCB, which makes, you know, working on the PCB easier. If we're pulling it out, there's a problem with the PCB. But it's kind of nice for people, I think, to have the option of just an individual motor, you know, if that's all they want to do, test or whatever, connect. So I think one other thing you need is these 3 boards need 3.3 volts logic to power all their logic, the ICs, and for that you need a switch mode regulator. Now these are available on eBay or AliExpress for like $1 each or something. You have to tune it to 3.3 volts first. Then just run that output. I like to run it into, well, first this is coming from a 12 volt battery. You can use, I think it's up to about 36 volt power supply. You can use one of these traditional power supplies here if you like, but a battery works fine. Note that that will affect the motion of your motor. I mean, if you use a higher voltage battery, the motor is going to travel faster on average. I usually connect the battery with a button so that I can, you know, turn the circuit on and off very easily without having to disconnect a terminal. So that goes into your voltage regulator. The interesting thing is any voltage, once you set that voltage regulator, you can use any voltage battery to produce that 3.3 volts, which is really an amazing thing when you think about it. It's basically going off of some semiconductor voltage drop. So it will basically, once it's set to 3.3, doesn't matter if it's 24 volts or 12 or whatever, it will stay at 3.3, which is one of the coolest things about these switch mode regulators. That's pretty much it though. Then you just have to program your code. But this is mostly just a build video, how to construct this thing.